Hello guys, welcome to another session of Math. Let's look at this problem. Find x if 3 raised to the power 2x minus 3 raised to the power x plus 2 plus 8 is equal to 0. Find x if 3 raised to the power 2x minus 3 raised to the power x plus 2 plus 8 is equal to 0. How are you going to find the value of x from this equation? Well, if you can, pause the video and try. Or let's get started to find out how s can be determined from the equation here. Okay, so let's write our solution first. Now let's bring this equation down here. Three raised to the power 2x minus 3 raised to the power x plus 2 plus 8 is equal to 0. Well, to get the value of s from this equation, we are going to use the substitution approach. Just going to use the substitution approach to find the value of s from this equation. Okay, but before we will apply the substitution approach here, I'm just going to rewrite this one and also rewrite this one, and then after that we will do the substitution. Okay, now the substitution will be for to replace 3 raised to the power x, 3 raised to the power x. Okay, good. Yours, you can also, if you can only deal with the algebra, you can also maybe find another variable to replace the whole of 3 raised to the power x plus 2, or maybe if you have any other approach that you can use to solve this one, that one is also good. But here I just want everything to be very, very, very simple for you guys, so I'll just take my time and then work it out for everybody to get its portion. Okay, I will not include any complex calculation here. I'll just make it very, very, very simple. Okay, the substitution that I'm going to do will be very, very simple to understand. Okay, but if you think you are good, and then you can use substitute the whole of maybe this one for any variable or for any blah blah blah, no problem, you can do that. But here we're just going to take our time to work everything out. Okay, good. So as I said, I'm just going to rewrite this one and also rewrite this one before we do the substitution. But first I'm just going to rewrite this one. 3 raised to the power x plus 2, x plus 2. Now this one here is the same thing as 3 raised to the power x times 3 raised to the power 2. You know, from the laws of indices, when the base are the same and it's multiplying, we just add the powers. Okay, so if you are having something like 3 raised to the power x plus if you're having something like 3 raised to the power x plus 2, all we have to do is just to convert it back. Okay, so we're just going to rewrite this one as well. 3 raised to the power x times 3 raised to the power 2. Okay, good. Three raised to the power 2x minus 3 raised to the power x times 3 raised to the power 2 plus 8 is equal to 0. Okay, so here 3 raised to the power x times 3 raised to the power 2. This one, the value for this one is 9, right? The value for this one is 9. So this one can also be written as 9 times 3 raised to the power x. Okay, Good. Now you see this one is has been what we have all rewrite this one from this state to this state, and you could see that when we do substitution, it will be very very simple for us, because this one where we say maybe y is equal to 3 raised to the power x, you exactly know where 3 raised to the power x is. But when you come here and then I tell you that let y be equal to 3 raised to the power s, you find it a little bit difficult doing so, because here it's not 3 raised to the power s but 3 raised to the power x plus 2. I know some of you can let variable be equal to the whole of this and then do the algebra, and at the end of the day get the same answer that we are going to get for this, but I'm actually not concentrating on that. So I just want the solution to be very simple, so that everybody will be able to get the understanding from it. Okay, so here we have managed to get 3 raised to the power x here. So here what we are going to do here is that I'm just going to rewrite this one so that it will look like this one here, so that when we do the substitution, this side and this side will be affected what at once. Okay, so I'm just going to rewrite this one as well. 3 raised to the power s as this one, then we power it to what these two here. Okay, good. Now you see that into bracket 3 raised to the power x squared minus 9 into bracket 3 raised to the power x plus 8 is equal to 0. Now you can see that when we do the substitution, everybody will know what is going to replace the variable that we are what is going to replace what any of the either the figure or maybe the number here. Okay, so we are going to do the substitution, because from here it is very simple to do the substitution. And anytime when you do the substitution right from here, you could see that it's very simple and easy to understand. Okay, so you're just going to let u be equal to 3 raised to the power x, and now when we do that, you easily know where you are going to replace what the y as compared to the original one. Okay, now when I say let m be equal to 3 raised to the power x. Now when you come to this equation, you just go when you come here, just here we are having 3 raised to the power x, we just put what m there. When you come to this side, just having what 3 raised to the power, just put it there. But assuming this side is s plus 1, what are you going to put there? The question says let y be equal to 3 raised to the power x, but here is the case we are having s plus 1, so you find it difficult. So if you have it that, when you get it that, when you have problems of this nature, you just try and then work it out as I have done mine, and then you see that it will be very simple for you to solve. Okay, so now let's do our substitution, because from here it's very simple and clear to do the substitution. Okay, so now we are going to let u be, I'm going to use u. You can use any variable at all, any variable at all, but make sure you don't use what is in what the question. I mean, here we are having x, make sure you don't use x. If you use x, make sure you do some adjustment to it, maybe x1 or maybe something like, make it a little bit different from what is in what the question. Okay, so here I'm going to let u be equal to, then I let u be equal to 3 raised to the power x. 3 raised to the power x equal to u, or u is equal to 3 raised to the power x, anyhow you do it, because an equation both and left hand side are the same. So 3 raised to the power x is equal to u, or u is equal to 3 raised to the power x, anyhow you do it, it's okay. So wherever you see this 3 raised to the power x, you're going to replace it with this u here. So as I was saying, now when I come to this equation, I know where wherever I see 3 raised to the power x and not 3 raised to the power x plus 1. When I come here, it's what 3 raised to the power x. When I come here, it's 3 raised to the power x. So I just put what my u there, and it's very simple as compared to 3 raised to the power x plus 1. That one I'll find difficult getting what 3 raised to the power x alone. Okay, so here we just put u here, and also just put what u here. Okay, why we have to do the substitution, so that we can get the value of what x easily. I'm saying easily because somebody will not do the substitution, but I will still be able to work this thing, the whole of this thing out, and get the value for x. Okay, so let's replace this one with what, this u here. So after the substitution, the equation is now u squared minus 9u plus 8 is equal to 0. U squared minus 9u plus 8 is equal to 0. Now, how are you going to find the value of what? U. Well, here, you can use either we can use the graphical approach. We can also use the quadratic formula. It's a quadratic equation though, but we can use the quadratic formula, or you can use the factorization approach or the completing square approach. Any of these that you can use, it will help you what? You will get your value for what? U. But here we are just going to what? Use the factorization approach. We're just going to factorize this one. Okay. So how are you going to do the factorization? Well, u squared minus 9u plus 8 is equal to 0. If you want to use the factorization, it has what, some procedures that you have to follow. First, it says multiply the coefficient of x squared by the constant. Multiply the coefficient of x squared by the constant. After that, find factors of that product. Find the factors of that product. Then from that factors, find any two of them, those factors that when you multiply it, it will give you the product of what? The coefficient of x squared or u squared and the constant. But when you add it, when you add it, it will give you what is here. What is here. Okay, so the coefficient of u squared is what? 1. And the constant here is what? 8. So 1 times 8 will give us what? 8. Now, what are the factors of 8? We have 4 and 2, minus 4 and minus 2, minus 1 and minus 8, minus 8 and 1. We have a whole lot, but to go fast, the factor that can, when we multiply, that will give us the product of this, the coefficient of this and this. And also when you sum it up, it will just give us this one here is what? Minus 1 and then minus 8. Minus 1 times minus 8 will give us what? 8. Negative times negative will give you positive. So, and negative minus negative will give you what? Negative answer. So, minus 1 times minus 8 will give you what? This 8 here. Minus 1 minus 8 will give you what? This minus 9 here. Okay, so we're just going to replace this minus 9 here with what? U minus 8u. Okay, good. Here we are just going to bracket this and this, and also bracket this and this. Okay, good. Here we are going to find what is going to come out. What is going to come out here? The common one. Here we are having u squared, and here we are having what? U. So here we are having 2u, and also here we are having what? 1u, meaning u is common here, so we can bring u out. Now, when we bring u out, here it will be left with what? U, and then here we are having u, so when we bring that one out, you left with what? Only 1. Okay, so here when you bring u out, what will be left in the bracket is u minus 1. Okay, now when we come here, we are having 8u plus 8. We are having u here, but there is no u here, so u is not common here. Here u is not common, but this side u was common, so we brought u out. But here we can't bring u out because it's not common here. We are only having 8 at this side and not here. Now, let's look at the 8. Here we are having 8, and also we are having 8 here, meaning 8 is common. When it comes to this one, 8 is common here, so we can bring 8 out. So we are having 8u. So when we bring 8 out, it will be left with what? U. And here when we bring 8 out, it will be left with what? 1. So here it will be left with u minus 1 because of this negative here. Okay. So After bringing the common factor out, that is what we have gotten. That is u into bracket u minus 1 minus 8 into bracket u minus what? 1. And all equal to what? 0. Alright, so here we are having this one here is same thing as well, this one here. Okay, so we just pick one of them. And then we will just pick this, and then we just put it into another bracket. Okay, so that is going to give us u minus 8 times u minus 1. Okay, or multiplication is commutative, so anyhow you do it, either u minus 8 times this or this times that. Anyhow you do it, you're just going to get the same answer at the end of the day. Okay, now u minus 1 times u minus 8 is all equal to 0, so you're just going to equate each of them to 0, and then we find the value of what? U. Okay, so first I'm just going to equate this one, and then later on we just equate this one. Okay, so u minus 1 is equal to 0, so u is equal to 1. So that is the value of what? U from the equation. Okay, now let's look at this one. Or u minus 8 is equal to 0. U is equal to what? U is equal to 8. Now, the value of u from the equation we generated from the original one is what? 1 and then 1 and then what? 8. The 1 and 8 that we have just gotten is not the answer to the original equation. No, it is the answer to the equation we generated from the original one after the substitution. Anytime you do the substitution, the values that you get are for the equation you generated after the substitution. So if you want to get the original equation, the value for the original equation, or the value of that variable from that original equation, you have to equate what you had to what you substituted that variable for. Okay, so here we are having u is equal to 1 or what? 8, but that is not what we are looking for. That is not the answer that we are looking for. We only did the substitution to help us what? Solve our problem. So to get the value of what? X from the equation, we have to equate those values that we had for u to what we substituted the u for. That is for 3 raised to the power of x. Okay, so to find the value of x from the original equation, we are just going to equate 1 and then 8 to 3 raised to the power x. Then we solve that one, and whatever that we will get from that one will be the answer to the original equation. Okay, good. So here, but u is equal to 3 raised to the power x. Here I wrote u is equal to 3 raised to the power x because we are not looking for u, but rather we are looking for what? X. Okay, we only find something to replace this one to help us solve our problem. So if we are done, we have gotten value for this, there's nothing that should hold us back from finding the value of this. Yeah, so we are just going to equate the value of this one to this, and then we solve that one also. Okay, so let's take the one. So 3 raised to the power x will be equated to what? The first value, that is what? The 1. So 3 raised to the power x equal to what? 1. Supposed to be u, but the value for u is what? 1. Okay, so 3 raised to the power x equal to 1. How are you going to solve this one? Applying logarithm. If you apply log here, you're just going to get I don't know if it's going to work out. Yeah, you can take log and it will work out for you. Okay, but here we know that from the laws of indices, any number raised to the power 0 is what? 1. So here we can rewrite this one here as 3 raised to the power 0, 1000 raised to the power 0. We all know that any number or any variable raised to the power 0 is what? 1. So if you want to get the value of s from this equation, we just have to choose what? 3. If here is 1000, we choose 1000. B, we choose B. So if here is 3, just write it as what? 3. So I'm just going to equate this one to 3 raised to the power 0. Good. Now you could see that 3 raised to the power x is now equal to 3 raised to the power 0. Now you could see that the base here and then this base is also the same. Now since the base are the same, the powers too are the same. That is from what? Exponential equation. So by exponential equation, x is equal to what? 0. X is equal to what? 0. Okay. So by exponential equation, x is equal to 0. So the value of x from the original equation is what? The first value is what? 0. 0. That means when we put 0 into the original equation, both left and right hand side will be what? The same. Okay. Now, what about the other value that we had? That is the 8. So let's equate 3 raised to the power x to that 8 also, and let's see what we are going to get at the end of the day. Or 3 raised to the power x equal to 3 raised to the power x equal to 8. How are you going to find the value of x? Here, if we decide to use indices as we did for the other one, it won't work, because this one, if you write it as indices as this one is looking, it can be written as well 2 raised to the power 3 is the same as what? The 8. There's no way we can write 8 using what? A base of 3. No, we can only write 8 using a base of 2, and then we power it the what? The 3. Okay, so we can't use indices here. So here we will not get any significance or any whole number here. I think you're going to get decimal, because you're going to apply logarithm to solve this one. Okay, so here you're just going to take log of both sides. You're going to take log of both sides. Take log of this, also take log of this. The motive of taking log of this is to bring this one down so that we can get it stand alone on the other side of the equation, and then equate it to the other side, and then we find what? The value here. Since this one is not here and we cannot write this one in any way to look like this one, we can't find the value of this x here unless we use what? Logarithm. Okay, so let's take log of both sides. Take log of both sides, logarithm of both sides. You can take natural log or log of both sides, any of them that you take. This is going to get the same answer at the end of the day. Okay, so log of 3 raised to the power x is equal to log what? 8. Log 8. And as I said, the motive of this one is to just bring this x what? Down. Okay. Now, when the base is not written, the base is what? 10. When the base is not written, the base is what? 10. We can choose to solve this one at once by taking log to the base of 3. You know, when we take log to the base of 3, the log with the base 3 will cancel out with this 3 here, and to be left with what? X. But we didn't do it that. We can do it that one also, and we're just going to get the same answer as what we are going to get here. Okay, so here from the laws of logarithm, this x here can be written at the back here. Okay, so x log 3 is equal to log what? 8. Now, how are you going to find the value of what? X. We just divide both sides by what? Log 3. Okay, so let's divide both sides by log 3. Now, here, this will cancel out with this, and we're left with x. So x is equal to log 8 over log 3. Log 8 over log 3. And, you know, from the quotient law of logarithm, this one can be written as what? Log 8 over 3. Log 8 over 3. You know, when you have it something like that, you can write it out this form. Okay, now this is what the value for what s, the other value for s from the original equation. This one to this one, when we can put it on the calculator to find what the actual value, I mean the numerical value of this. Okay, now when you punch it on the calculator, this is what you're going to get. So x is equal to 1.892 blah 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 blah. The decimal places are many, but I choose this only 3 decimal place. Yeah, I choose only these 3 decimal place. So the numerical value for this one is 1.892. There are others, but I just choose these 3 decimal place here. So x equal to 1.892. Please don't say 1.892 because after decimal point, all numbers that are there are all insignificant. You can't you mention them one by one. You can't do it as we do for maybe like 10, like maybe 80, something like that. Something like that. There's no way you can say 1.892. No, you are wrong. 1.892, you are wrong. After decimal point, all those numbers, they are insignificant, meaning all of them are all less than 0. Less than 0. And you can see that here is 8. This 8 is bigger than 1, but here we are saying 1.8. So you see, meaning this 8 is what? Less than what? 0. It's not up to 1. It's not up to 1. If this 8 is up to 1, this one could have what? Come here. Okay, good. So x is equal to 1.892 blah blah blah. When you punch it on the calculus, you see the others, but I just choose this. Okay, so therefore x is equal to 1.9. X is equal to 1.9. That is to one decimal place. Now here I will suggest that when the question doesn't state what the number of decimal place that you should leave your answer in, make sure after computing any figure, make sure, and then maybe you have decimals, make sure the decimal number of decimal places that you leave your answer in is what? 4. Generally 4 decimal places is okay, but here I choose to omit the other one. But doesn't matter, but make sure yours at least 4 decimal places is okay. 4 decimal places is okay. Only if the question doesn't specify. If the question restricts you or specify that maybe your decimal place, you leave it your answer in what? 2 decimal place, 1 decimal place, 3 decimal place. Yeah, I did this one just to talk about that. 1 decimal place, 2 decimal place, blah 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 blah. Make sure you do that. If you don't do that, you are wrong. But if the question doesn't say anything about decimal places, just leave your answer in what? 4 decimal places. Only if it is what? Terminating. Even if it is terminating decimals and it is more than 4, just leave your answer in 4 decimal places. Okay, but and also if it is non-terminating decimal, you can also the same thing, leave your answer in what? 4 decimal places. That one is safe. That one is safer than writing the whole decimal places over there, or writing 1 point, just choosing your own decimal places and just writing that one as your answer. That one will affect you because you don't know how the marking scheme is going to state the final answer. Okay, but here, as I said, I just choose to convert it to 1 decimal place just to talk about what I just said. Okay, so x is equal to 1.9. That is what? 1 decimal place. And when you are converting it to decimal places, I mean 1, 2, 3, you just after the decimal point, if it is 1 decimal place, just after the decimal place, just look at the first number or the first figure there. If the first figure is between 0 to 4, we take it as what? 0. If it is between 5 to 9, we take it as 1, and we add it to what? The first figure. So the first one, you could see that it was 1.892, right? So converting it to 1 decimal place is going to be 1 point. Then the first figure is what? 8. Then the next one is what? 9. So 9 falls between 5 and then 9. So we just take it as 1 and then we add it to what? The first figure. That is how come we had what? 1.9. Okay. So x is equal to 1.9. So therefore, x is equal to 0 or 1.9. So the value of x from the original equation is what? 0 or 1.9. So if you put either 1.892 blah 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 or 1.9 to the equation, you can see that both left and right hand side will be the same. Or if you put 0 into the equation, you can see that both left and right hand side will be what? The same. Okay. All right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching, and I'll see you in another video. Bye for now.